This is the Unit 9 periodic table review and trends. Okay, let me double check that my recording is still recording. There it is. Okay. And I don't know why it's doing that today. That's okay. All right. So we're going to start with just part 1, which is just the periodic table review and the atom. And really, we just need to remember that we have the structure of the nuclear atom, and that is made up of 3 subatomic particles. And that would be the electron, which is negatively charged, and it has a -1 charge, and it's really tiny. So we say it's 1 over 1,840th of the mass of a hydrogen atom, and a hydrogen atom is pretty small. But you don't have to know the exact number, but you just need to understand that it's really small. Also, the other thing that probably ought to say on here is that it is located outside of the nucleus. Our other particles that we have in our atom are the proton, and it's a positively charged subatomic particle. It is in the nucleus. And then we have our neutron, which has approximately the same mass as a proton, and it's more massive than the electron. And it is located in the nucleus with the proton, and it has no charge. So you really just have a positive charge and a negative charge and a no charge, and that would be your proton, neutron, and electron. And you have inside the nucleus and outside the nucleus. And so the proton and the neutron are found inside, and the electrons found outside. Now, the nucleus is the central core of an atom, and it's composed of the protons and the neutrons. And because the protons and neutrons are inside the atom, they don't get to move around a whole lot. And so only the electrons, which are outside, and they're in things called energy levels or orbitals. And because the electrons are on the outside of the nucleus, they get to move around. But since the protons and the neutrons are in the nucleus is positively charged, and it also accounts for 99% of the mass of the atom. Okay. Now, how do we tell the difference between atoms? We look first at their atomic number. The atomic number is the number of protons in the nucleus of an atom. So all the numbers on the periodic table for each element are actually telling you how many protons there are. If that proton number changes, then it changes what element we're talking about. Now, the mass number, on the other hand, like I said, is the protons and the neutrons added together in the nucleus. So the number on the periodic table that's on the bottom is actually an average of all the numbers of all the different isotopes of that atom. So what's an isotope? An isotope is an atom that has the same number of protons, so that keeps it the same element, but it has a different number of neutrons, so it has a different mass. Okay, so that isotopes are really just the same atom with a different mass number because of the different number of neutrons. Now, we could find the missing values for neutral atoms. A neutral atom, remember, means where the protons and the electrons are equal to each other because all the positives cancel out all the negatives. So that's important to remember, is that neutral means that the protons are equal to the electron numbers. So you should be able to fill out a chart like this. The atomic number tells you the number of protons, so that would be 12. And if you look up 12 on the periodic table, it is magnesium. And then the protons should equal the electrons since it's neutral. And so these should be equal to each other. And then, and then the neutrons are found by doing the mass number minus the proton number, which, again, you could write that as the atomic number too. So we would take 25 minus 12, which would leave us with 13. Okay, then the next one, if the atomic number is 6, or sorry, if the proton number is 6, then the atomic number is 6. That also would mean that the electron number is 6. And in order to find the mass number, we would do the protons. I really am having issues drawing today. We would have the protons plus the neutrons. So we would have the 6 protons plus the 6 neutrons, which would be 12. And then we'd look up what is element 6. It is carbon. Okay. Then we could look for potassium on the periodic table. It is atomic number 19, which means it has 19 protons. It also would mean that it has 19 electrons. And then we would do 40 minus 19, which would tell us there's 21 neutrons. Finally, if there's 23 electrons, there's 23 protons, and the protons matches the atomic number, so that would be 23 there. We look up 23 on the periodic table, and it's vanadium. And then to find the mass number, we would do our 28 plus 23, which would give us 51. Okay. Hopefully, again, that you can fill out a chart like this. All right. Now the atomic mass, which is what's listed on the periodic table. Remember, these are the weighted average masses of all the atoms in a naturally occurring sample of an element. So really, it's like I said, it's the average of the abundance of the isotopes. So that's why all of them have decimal numbers. Okay, the original periodic table was set up by Dmitri Mendeleev. Okay, Mendeleev's table was arranged according to atomic mass. So you do need to remember that. The elements with similar properties he put in the same vertical column, all right, which actually carried over to the modern day periodic table. And then he actually had some blanks, and so he realized that there must be some missing elements that were yet to be discovered. So there were some holes in his when he had it arranged this way. Henry Moseley actually came about and rearranged it. He was a British physicist, and he decided to do the periodic table by atomic number instead. And so he arranged his periodic table that way. And his periodic table, like I said, is the one we use today. And he also still had some blanks, and he put similar properties. He set it up still so that similar elements with properties were in the same columns with each other. So again, his had holes also, and that's what led to a lot of the discoveries on the periodic table. So periodic law is when the elements are arranged in order from increasing atomic number, like they are on the periodic table today. There's a periodic repetition of their physical and chemical properties. This is periodic law, is that when they're set up this way, there's always this repetition of similar physical and chemical properties, and that leads us to be able to make a lot of trend characteristics. We're able to say a lot of things about all of the elements because of these repetitions that happen. Okay, so just a couple of reminders about your periodic table. Remember, the periods are the horizontal rows. They also tell you the number of energy levels. So this would tell you kind of like a Russian nesting doll. If you think about it, there's a larger level, and then if you take off a doll, there's a smaller one inside and a smaller one inside. That's kind of like a visual for what energy levels are. Energy levels are where we're going to find electrons. And so there's a maximum of 7 energy levels because there's a maximum of 7 periods on the periodic table. Groups are your horizontal, vertical columns on the periodic table, and they are also called families sometimes, okay? And so those are just your vertical columns. Then we have the group A elements. These have a number and an A after them. There are 8 of these, and these are called the representative elements. Okay. In the representative elements, we have some family names. So group 1A is the alkali metals. Group 2A is the alkaline earth metals. And then group 7A is the halogens. And group 8A or group 0, depends on what periodic table you're looking at, are the noble gases. So again, like I said, these are, with the A's are all representative elements. And then we have some specific names. Okay, this group also happens to be 3A is the boron family, 4A is the carbon family, 5A is the nitrogen, 6A is the oxygen, so just the first element in those. But the other ones, the 4 that aren't named after their first element, is these. I will say, actually, hydrogen is in this group, but it's not an alkali metal, so just FYI. Okay. The group B elements, which are the ones here in the middle, okay, and these that fit up in it, they are known as the transition metals. And then the 2 rows down at the bottom are known as the intertransition metals because they fit up in there, okay, or the rare earth metals. So I'll remind you that on the periodic table, the metals are going to be found on the to the left of the staircase. Remember, the staircase is right here between all these elements. Okay, so anything this direction is considered to be a metal. Okay. Anything to the right of the staircase is considered to be a non-metal. Okay, so these are all considered to be nonmetals. And anything touching the staircase except for aluminum are considered to be metalloids, and they kind of have properties of metals and nonmetals. Okay. All right, so that's part one, and I will do another recording for part two.